Hello class, this video is intended to help you find a p-value from a t-test procedure using a t-table. The first step is, of course, doing any hypothesis test is to calculate a t-test statistic. Then we should always find the associated degrees of freedom. The degrees of freedom will be found depending on which type of test you're doing, if you're doing a one-sample t-test or a two-sample t-test. So after you find the corresponding degrees of freedom, we should always then find the p-value. We can do this by scrolling across the row of the determined degrees of freedom, and then once you find the columns in which the test statistic falls, because it'll probably be unlikely that you'll get exactly the same test statistic value as a particular column, so you'll probably find a range. You'll need to then find the p-values at the top of the columns. This will then be a range for the p-value instead of an exact p-value like we found when we were using a z-table. So for our first example, we will find we have a t-test statistic of 2.56 for 16 degrees of freedom. We want to find the one-sided p-value and the two-sided p-value. So how can we do that? Well, we should go over to our t-table, which is here. So we go to our t-table and we scroll down until we find our degrees of freedom that we're interested in. So this will be 16. Again, that was the degrees of freedom. Make that a little wider. There we go. And then we scroll across until we find our test statistic, or where it falls. Well, our test statistic, if we recall, was 2.56. So we come back here, it says 2.56, keep going, and we see that our test statistic will fall between 2.120 and 2.583. So that means that we should then go up these two columns, and our one-sided p-value then will be between 0.025 and 0.01. And our two-sided p-value will be between 0.05 and 0.02. So come back to our example, and we can write this up as our one-sided p-value will be from 0. So our one-sided p-value will be from 0.01 to 0.025, and the two-sided p-value will then be from 0.02 to 0.05. Therefore, if we had a significance level of 0.05, we would reject in the one-sided and two-sided case. If we had a significance level of 0.01, we would fail to reject on both of these cases. All right, so let's do another example. So now we have a t-test statistic of -6.98, and our degrees of freedom is equal to 74. So we need to first find then our degrees of freedom. So we scroll down and we find that our table actually cuts off between 60 and 80. So what we should always do when we have a degrees of freedom that is not on our table is to round down. So we go and use our 60 degrees of freedom. This will give us a more conservative estimate and p-value. Now we had this test statistic of -6, go back, let's see, -6.98, and we find that if we scroll across and we use the absolute value then, keep going across our table, we find that it's actually not on our table. It would fall off the table. It's a pretty extreme test statistic, and so what we can do is to do the p-value. If it's much bigger than what's in our row, then we say that the p-value for one-sided is going to be less than 0.0005. And for two-sided, the p-value would be less than 0.001. So here, p-value is less than 0.0005. And in this case, then the p-value is less than 0.001. So if it's out of the range of the table, then we just use the very last value, and we would know that if it were more extreme than the last value on this table, then it would have to be a smaller p-value than that, because you can see the p-values as we go across the row are actually getting smaller. So the p-value, if we could keep going on this table, would be much smaller than 0.005 for a test statistic of past -6 for the 60 degrees of freedom. Okay, so let's do one more example. So our last example says we have a t-test statistic of 0.76 with 6 degrees of freedom. So let's go back to our t-table to find then the p-values. So we need to first find our degrees of freedom. We scroll down, find 6, and we had a test statistic of 0.76. So if we scroll across the row, we find that our test statistic falls between the 0.718 and 0.906. Therefore, if we go up these columns, we can see that a one-tailed p-value will be between 0.20 and 0.25, and a two-tailed p-value will be between 0.4 and 0.5. Note that one-tail and two-tail is essentially just one-sided and two-sided. It's just slightly different terminology. So we come back here and we have then 0.20 to 0.25 for our one-sided p-value, and for our two-sided p-value then we have 0.40 to 0.50. Now notice on each one of these, the two-sided p-value is just 2 times the one-sided p-value. This is an easy way to then just find one, and if you have a two-sided test, just multiply your p-value by 2, and you will have your two-sided test.